Okay, so let's get started with the second lab for the mugwort risk v SV6. This is the orientation, and the lab 2 is um, recommended to take after you learn the basic concepts by my tutorials regarding the book Operating Systems 3 Easy Pieces. Um, so OSTP is a good book to get started with operating systems. So Lab 2 is about system calls. System calls are basically the traps that you make from the user application for the kernel or to execute some code in the supervisor mode. The idea is actually quite simple, but the implementation is complicated. So you have to be aware that there are three risk v privilege modes: the machine mode, the supervisor mode, and the user mode. And the equal is what we use to go to a jump to a more privileged mode. So when you use equal in user mode, you will go to the supervisor mode. When you use equal in the supervisor mode, you would go to the machine mode. Now, a good example of the using equal is the fork. The fork is a wrapper within the C library. To be more exact, it is in the uses.s. S stands for assembly code, and here is uh, the code, assembly code for fork. So the way we would use the fork function in the C code is you do something like this. So basically what fork is you create a new process, right? And it returns the process ID of the new process. And when you do this, basically C says, okay, get the fork assembly code from this file and run this code. It's just very simple. That's why it's just called a wrapper, because it's a simple line of code. What it does is basically here this fork is the number for the fork, and it saves to A7, which is the register that would that saves the number for the trap handler, and then it calls equal. So when we call equal, the content of A7 is used as the number for the trap handler, and the content of the A7 is the number for the fork trap handler. So it basically goes to the fork trap handler in the supervisor mode, and And then after that, it returns. So it goes back to this one here. But I guess, so why do we use a wrapper for fork instead of, doing something else? First, we do not have to write assembly. If we just need, we can just stay in the C code, C style of coding, if we use fork. So a lot of developers can't be bothered to use assembly. And the system call number. So you do not have to know the system call number for fork, which is saved in this code uh, as a variable, as you can see here. I mean, so basically you can see that now you know how the fork actually works in a C code. And now whenever you are calling fork using a line of code like this in C, now you are sure that, wow, it's gonna save the system call number for fork in A7 and then do a eCall. Only if you're in a RISC-V system though. Now, one other ISA that we will have to consider, since it's so prevalent, is the x86-64, right? The x86-64 is basically, it's what probably used the most. It's used the x86 family initially created by Intel, and then AMD created the AMD 64, which is an extension of the x86 32-bit. So it's now in 64 bits. So when you use x86-64, now most Linux will be with x86-64. Some Linux will be with ARM, like ARM 64. It's what ARM made. It's the also called like this. But well, the ARM 64 we're not gonna worry too much about. We're going to focus on the RISC-V and somewhat x86 64-bit. So one thing that you have to know is in x86 64, it's syscall instead of ecall. So when you call fork in a C program in Linux, you're gonna call a wrapper. Again, a wrapper, similar to this. Wrapper means it's a simple code that just wraps around a important line of code, which in this case is ecall or syscall. So it executes the syscall instruction in a similar manner in the x86 Linux. Okay.